When you look up at the night sky, you see a lot of tiny twinkling stars. But have you ever wondered how far they are? Which one is closer? Which one is not? Well, I don't know, but astronomers do. And the way they measure these vast distances is nothing short of mind-blowing. Today we are diving into the fascinating methods used to measure the distance to stars, from ancient tricks to cutting-edge technology. Trust me, by the end of the video, you will feel like a cosmic detective. Let's start with the simplest and oldest method, parallax. Well, to understand parallax, let's do an experiment with me. Hold out your thumb in front of you. Now close one eye. You see your thumb? Now switch to the other eye. You see your thumb seems to move a bit? That's parallax at work. Well, now let's see how astronomers use this parallax method to measure the distance of stars. When astronomers observe a nearby star from two different positions in Earth's orbit, the star appears to shift slightly against the background of distant stars. The shift is tiny, but by measuring the angle of this apparent shift and knowing the distance between those two observation points, they can calculate the star's distance using basic trigonometry. Think of it like forming a triangle. The base is Earth's orbit, the two sides are the lines of sight to the star, and the angle is the parallax shift. By applying some geometry, the distance to the star can be pinpointed. Cool, right? It's like having a giant cosmic measuring tape. The first star measured using parallax was 61 Cygni in 1838 by German astronomer Friedrich Bessel. Parallax is an excellent method for measuring distance to nearby stars, but it has a significant limitation. It only works within a relatively short cosmic range. Beyond a few thousand light years, the shift in the star's position against the background of distant stars becomes so minute that even the most advanced telescopes struggle to detect it. This means that for galaxies and stars further out in the vast universe, parallax simply can't give us the answer we need. That's where our next cosmic tool comes in: standard candles. So what exactly are standard candles? Imagine you have a light bulb whose brightness you know perfectly. If you see it shining dimly in the distance, you can tell it's far away. That's the whole idea. Standard candles are stars whose true brightness we know really well. And by measuring how bright or how dim they appear from Earth, we can figure out their distances. One of the most famous type of standard candle is the Cepheid variable star. These stars are special because they don't shine steadily. They pulse like a heartbeat. And here's the cool part: the slower the pulse, the brighter the star. Here's how we use Cepheids to measure distance. First, we observe how long it takes for the star to pulse, from brighten to dim. That tells us its true brightness. Then we compare that true brightness to how bright it looks from Earth. If it looks faint, it's far away. If it looks bright, it's closer. Simple, right? Think of it this way: you are driving at night and see two cars' headlights at a distance. You already know how bright the headlights are supposed to be. So if they look very dim, you know the cars are too far away. That's exactly what astronomers do with Cepheid stars. Except instead of cars, we are talking about stars thousands, even millions of light years away. So far we have talked about parallax for nearby stars and standard candles for further ones. But what if we need to measure the distance across the entire universe? That's where things gets really interesting. Let me introduce you to the most groundbreaking and popular method in astronomy, the redshift. Before we dive into redshift, let's talk about something mind-blowing. The universe itself is expanding. Imagine blowing up a balloon. As it gets bigger, the dots you have drawn on its surface moves further apart. That's exactly what's happening in space. Galaxies are moving away further from each other. The fabric of the universe is stretching. But how do we know that galaxies are moving away? That's where the redshift comes in. So, what is redshift? To understand it, think of sound. You know how a car horn sounds? Higher pitched as it comes towards you and lower pitched as it's moves away, right? That's called Doppler effect. Well, light does something similar. When a galaxy moves away from us, its light stretches out, shifts towards the red part of the spectrum. That's called redshift. That means the more redshifted the light from a galaxy is, the further it is moving away from us. By analyzing this redshift, astronomers can measure not only the galaxy's distance, but also how fast the universe is expanding. Redshift has completely transformed how we see the cosmos. It's not just about measuring distance, it's about uncovering the universe's history, its future, and even its ultimate fate. From nearby galaxies to the very edge of the observable universe, Redshift is our ticket to understand the grand scales of existence. Okay, so far we have traveled through the universe using Parallax, standard candles, and Redshift. These tools gives us incredible insights, but today modern astronomy has taken precision to a whole new level. Welcome to the world of Gaia, a game changer in mapping our galaxy with pinpoint accuracy. For centuries, astronomers have worked tirelessly to measure distance in space. But as our tools get better, so did thrust for precision. How far is that star? How fast is it moving? What does our galaxy really look like? Enter Gaia, a mission that's revolutionizing how we see the Milky Way today. Launched by European Space Agency in 2013, Gaia is a space observatory with one goal: to create the most detailed 3D map of our entire galaxy. Gaia works by using a method called astrometry, which tracks tiny wobble in stars' position as Earth moves around the Sun. So how precise is it? Imagine being able to spot a coin on the Moon from here on Earth. Gaia also measures how star moves and how their brightness changes over time. Gaia has already uncovered some mind-blowing facts: new star clusters, rogue stars speeding through the galaxy, and even evidence of ancient galactical collisions. It's not just mapping the present, it's revealing the Milky Way's history and its evolution. If you want to know more about Gaia, let me know in the comment section and I will make a detailed video about it. So there you have it. From simple geometry to cutting-edge space telescopes, Astronomers has developed incredible ways to measure the vast distance of the universe. So next time when you look up at the stars, remember each one has a story. And thanks to these methods, we are learning to read them. So which of these methods fascinates you the most? Let me know in the comment section. If you like this video, don't forget to like and subscribe for more cosmic adventures. Until next time, see ya.